Today, my student friends, we are beginning with the chapter on inorganic chemistry, that is S block elements. Is clear? So, why would a group of element be called as S block? You know that in periodicity, we have divided the complete periodic table into four blocks. This was S block, this was P block, this was D block, and this was F block. So, what was the criteria for calling elements belonging to? So, elements belonging to group 1 and group 2. Elements belonging to group 1 and group 2. Group 1 and 2 of periodic table. Are called S block element. Now, why are they called as S block element? The basis of this classification is into which subshell did the last electron enter. So, the last or the differentiating electron, enters the outermost S subshell. So it is called as S block elements. So for group 1, the characteristic outer electronic configuration is is NS1. Whereas for group 2, the characteristic outer electronic configuration is is NS2. Now what happens is elements of group 1 are also called as alkali metal. Elements of group 1 are also called alkali metal. Now, how did you get the name alkali metal? The name alkali metal came from the Arabic word, alquis or alkali. Some books say alquis, or some say it is alkali, which means ash, wood ash, So wood ash was found to be alkaline, and wood ash is called alquis or alkali. And so such class of compounds, which resembled property of wood ash, they were called as alkali. Elements of group 2. Are called alkaline earth metal. They are called as alkaline earth metal. So what are the elements of it? So in group 1 you have hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. So while I am discussing this, I want to tell you this one multiple choice question which they can ask in the exam, that is, which are the liquid metals. You all have in your life experienced mercury as one metal which is liquid in nature. Yeah. So remember the other one is you have cesium and francium and gallium. So remember the four metals which are in the liquid state. We need this for our entrance exam. So while I am recording the lecture, I will also put forth some what you call data which is connected to the entrance exam. So remember what is it that we have is that cesium, francium, gallium and mercury are liquid metals. Remember that. Yeah. Then an alkaline method we have beryllium, magnesium, calcium, strontium, barium, and we have radium. Now, what we do is we'll be now talking about the occurrence and then the electronic configuration. We are now continuing and we are now going to talk about occurrence of these S block elements. As you are aware that sodium and potassium, and especially sodium, forms a very large part of what we call as the seawater, and it's also present in rock salt in land. So sodium and potassium. Sodium and potassium are abundant in nature. Sodium and potassium are abundant in nature. Then we have what we talk of potassium, rubidium. Rubidium is very rare. Rubidium abundance is rare. Abundance is rare. Cesium and francium. Cesium and francium are radioactive. Cesium and francium are radioactive. With francium 235 having a half-life period of around 21 minutes. Now you see in the entrance exam what happens is that while some questions are conceptual, analytical and there are also questions which are what we call as factual questions. So what happens? These kind of questions are there as a part of factual question. Their half-life period. And then when we come to alkaline earth metal, what happens? Beryllium occurrence is very rare. Beryllium occurrence is rare. But calcium is the fifth most abundant. Calcium is the fifth most abundant element on earth. And magnesium is the sixth. Magnesium is the sixth most abundant element. It is abundant over here. Sixth most abundant element on earth. As far as radium is concerned, you can see over here radium. Radium is a very rare. Radium occurs about 10 raised to minus 10% of igneous rock. Igneous rock. So this is all a short discussion on what you call the occurrence. We now have to proceed to the electronic configuration. We now talk about the electronic configuration of the alkali metals. Actually, I have not taken hydrogen over here. Hydrogen is 1s1. We only talk about what you call lithium, sodium, potassium, rubidium, silicium, and francium. So we have lithium atomic number is 3, sodium is 11, Potassium we know is 19. Then rubidium is 37. Then this will be 55 and this will be 87. So based on this atomic number, we write down the what you call electronic configuration or the arrangement of electrons in the shell around nucleus. So we have first electron entering the first shell. It can accommodate 2 electron, 1s2, and then we have 2s1. Here we have 1s2, 2s2, 2p6. So 10 are accommodated over here. So outer electronic configuration in this case will be 3s1. Then we have 1s2, 2s2, 2p6, 3s2, 3p6, and then we have 4s1. Then rubidium will be 1s2, 2s2, 2p6, 3s2, 3p6. Now you know that from 21 to 30, that is scandium to zinc, the 3d electrons are getting filled. So this is 37. So we will have 3d10, 4s2, 4p6, 5s1. Then this will be, now here, how will we know if 4f is not getting filled? 57 to 72 will be 4f getting filled. So this is 55. So 4f will not get filled over here. So we will have 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 5s2, 5p6, 6s1. 57 to 72 is lanthanized. So what happens there? The 4f is getting filled. So here you will have a configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 4f14, 5s2, 5p6, 5d10, and 6s2, 6p6, 7s1. So this can be also written in a very condensed form, which is accepted actually. Having the electronic configuration with respect to the nearest inert gas. I'll write in another color pen so that you can understand. So 1s2, 2s1. So 1s2 is actually helium. So we can say this is helium and 2s1. 1s2, 2s2, 2p6 is neon. So neon, then this will become 3s1. Helium, neon, 1s2, 2s2, 2p6, 3s2, 3p6 is argon 18. So 19, 4s1. Here we can write this as helium, neon, argon. This will become krypton. Then this will be 5s1. Okay, this way what happens is the helium, krypton, helium, neon, argon, krypton, this will be xenon. 6s1. And we can write this as xenon, radon, 7s1. So this kind of a what you call nomenclature, electronic configuration is also accepted. It is clear. So it becomes easy to remember. And then we now look at the electronic configuration of group 2 elements. We are now discussing the electronic configuration of group 2 elements or alkaline earth metals. So we have done already alkali metals. Now we are talking about alkaline earth metals. They both belong to S block elements. So we have lithium 3, beryllium 4. We have sodium 11, magnesium 12. We have lithium, sodium, potassium 19, calcium 20. So we have strontium will be 38. Barium will be 56. And radium will be 88. So the same way, we write down now the electronic configuration according to Aufbau principle. Yes, clear. So Aufbau was not a name of a person. Aufbau means to build up. It is clear. So according to that, what will we have? We'll have 1s2 and we'll have 2s2. So the outer electronic configuration here is 2s2. 2s2. Then we have 1s2, 2s2, 2p6, 3s2, 3s2. Then we'll have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. I told you. And we know 3d10 is because 3d10 starts, 3d1 starts with scandium, that is atomic number 21, the next element. Then we have 1s2, 2s2, 2p6, 3s2, 3p6. We'll have 3d10 because scandium to zinc, 21 to 30. This is 38, so 3d10 is getting filled. Then we have 4s2, 4p6, 5s2. We'll have 5s. Then we'll have 57. The next element, in fact, is where the lanthanide starts, 4f1. So this is before that. So we will have 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10. Okay? There is no 4f14. 5s2, 5p6. Okay. Then we will have 5s2, 5p6, and then 6s2. Here we will have 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10. 57 to 72. I told you will be 4f14 filling up. This is 88. So this is 4f14. I am purposely repeating 57 to 72 is because then you know the range of lanthanide elements starts from, in fact, lanthanum does not belong to lanthanide series. It's cerium, the first lanthanide element. So you will be able to later on remember. So this is a way of learning actually, you know. So 1s2, 2s2, 2p6, 3s2, 3p6, 4f14, 5s2, 5p6, 5d10, 5d10, 6s2, 6p6, 7s2. So like in the earlier example, we can bring it to, we can have an EC stands for electronic configuration over here with respect to the nearest inert gas. So 1s2 was helium. So we'll have over here helium 2s2. And here we'll have helium, this will be neon 3s2. Then this will be helium neon. This will can be written as argon 4s2. So this can be written helium neon argon. And this is krypton 5s2. Then this will be xenon 5s2, 6s2. And this can be written as radon 7s2. This is this kind of a mode of writing the electronic configuration is accepted in the board also. This is clear. So now we look at the next topic will be we start with anomalous behavior of lithium.